Hi guys, and welcome to this A-Level Maths Set A Paper 3 exam walkthrough. This is the applied paper. Paper 3 includes both stats and mechanics, and that's true for the video as well. As we work through this paper, you're going to see both the stats and mechanics part of the paper. Now, just a quick point to make here. For the mechanics part of the paper here, so the later half of the paper, the marks don't quite add up to 50, and the reason for that is because as I was working through the paper, I wasn't too sure whether to kind of add the extra question in so the marks do add up to 50, or whether to adjust the marks so that they do add up to 50 that way. So as I was working through it, I thought this, a little bit of a lengthy paper, and I didn't want to kind of overload the paper. So there's 11 questions in this paper, so I'm going to leave it as it is. So what I'll do is the actual PDF, I've already adjusted it. The marks do add up to 50 on the video, as you'll see. I think it's about 6 marks off, 5 or 6 marks. So that's why there's a discrepancy there between the actual video and the PDF of the actual paper 3. So nothing too concerning, and like I said, I think this will give you some good extra revision for the upcoming paper 3. So I think that covers everything. As always, if you are looking for extra A-level math revision, be sure to check out our website at AJMaths.co.uk. So that's everything. So let's get started here with paper 3. Starting off then with the very first question here on paper 3. So question 1, being given the random variable y, which follows a binomial distribution for parameters here of n equals 200 and p equals 0.52. So for the first part then, part A, just has to find these two probabilities here. So to find these two probabilities here, we're going to simply use our calculator. So for the first one then, we're looking for the probability then that y less than or equal to 96. Okay. So to begin with here, the first thing that I do to find this on my calculator is I go into stats mode. I'll just make a note here of how I'm doing this. So stats mode. Now, just a quick warning here, this might be different on your calculator, but I'm using a Casio graphical calculator, so it should be pretty similar for most people here. I go into stats mode, I then click on distribution, which is shortened to DIST on my calculator. So distribution. Then what it presents here is a number of different distributions. Obviously the one that you want, because we're working with the binomial distribution, is the binomial distribution. That's also shortened to BINM. That's for binomial. And then from here, you're given 3 different choices. But it doesn't matter which one you choose here, so you need to be careful. So your 3 different choices here. So the first one on the left would be BPD. One in the middle here is BCD. And the one on the right is INVB. Like we said, it doesn't matter which one you choose here. So for the first one here, for this probability, the probability that y is less than or equal to 96, this is a cumulative probability. You're going to work with BCD, okay? It would be BCD here, because this is a cumulative probability. For the second one, because it's an exact probability here, y is equal to 100, you would work with BPD, okay? So remember, use the C and P here to help. So the way that I used to remember this, if it's a cumulative probability, so C here stands for the cumulative probability, and P, I'm just going to remember that as precise. So exactly 100 is precise, right? So if that helps, just use that to remember. So in this case then, BCD here, that's what you need to click. And now it will give you a number of different options here. So the first thing that it'll ask for is the data. So it's either going to be a list or a variable. In this case, we're working with a variable. And it will also ask for X. It will ask for N, the number of trials here. And it'll ask for P. So X in this case, this would be this value here. This is what we're testing or looking to find the probability of. This would be 96. N, that's the sample size here. That would be 200. And then P in this case, that's the probability that we're working with. So again, using the parameters of our binomial distribution, that is 0.52. So all you need to do now is press enter. And what you'll get here, if I just make sure I get the right values in, that would be 96, 200, and 0.52. And just be careful here, make sure you give all probabilities for part A and part C to 5 decimal places. So what I'm going to get here then for this probability is 0.1424 there. Okay, so that's the 5 decimal places there. So that's the solution to the first one. Doing the same now for the second part here. Let me just do this in a different color. Do it in blue. So for the second part here then, we're looking for the probability that y is equal to 100. So in this case here then, it will be almost identical. The only difference here now is we work with BPD, because it's a exact probability or a precise probability if you want to remember it like that. So it's BPD here. So again, all you need to do now is go into BPD. And again, it lasts for the same things here. The only thing that will change now is X, because we're now looking for the probability that Y is equal to 100. So just make sure that you change X to 100 here, N would be the same, and P would be the same. So like I said, the only difference here is X equals 100. If you press enter here, this will give you the correct probability here. So again, if I make sure that I do the same on my calculator here, and I round it now correctly to 5 decimal places, I'm going to get 0.0481 there. Okay, that's to 5 decimal places. That's part A done. That's the first 2 marks. I know it seems like quite a lot of time just to do that, but obviously if you know how to find these probabilities here on your calculator, you can kind of fly through the first part. Let me just go back to my original pen colour here for part B. So for part B now, it says give 2 reasons why a normal distribution can be used to approximate Y and write down the parameters of such a normal distribution. You need to be aware here of the 2 conditions such that we can use a normal distribution to approximate here. So a normal distribution can be used to approximate Y for these 2 conditions here. So the reason why is because N is large. So typically we're looking for N being greater than 50, which in this case 200 is clearly bigger than 50, so N is large. So N is large. We're just going to say it's greater than 50 here. And the other condition here is that our probability is close to a half or 0.5. So we've got 0.52, that's close to a half. So B is close to 0.5. Let's put in a bracket here. We've got P equals 0.52 here. That just makes that a little bit clear. Okay, so that's the 2 conditions there. What we also need to do now is write down the parameters of such a normal distribution. So for the parameters here, remember we've got the mean mu here. And to find mu, we do N times P, so NP. Remember N here is 200, P is 0.52, so we get 200 times 0.52, which in this case here, that would give us 104. And then for the standard deviation here, sigma, this is going to be equal to the square root of NP times 1 minus P here. So I've run out of room a little bit here. So if I just find sigma over here, well, we know that NP, that's 104, so it's going to be the square root of 104 times 1 minus P, so 1 minus 0.52. All you need to do here now is just put this into your calculator here. So what I get then is the square root 49.92. So let's say we just give that to a sensible degree of accuracy here. We get 7.0654 there. Okay, I know we're running out of room a little bit here. Hopefully you can still see the parameters. So this is the standard deviation here, sigma. Okay, obviously you could give it in its exact form as well, which we will use later for part C. Okay, so do take a note here of part B if you couldn't answer this, because we're going to need this now for part C. If I just clear the screen here, let's take a look now at part C. So for part C, then it says find the percentage error in using the normal approximation to evaluate the probability of Y being equal to 100. So the first thing that you need here is this probability from the first part, the probability that Y equals 100. What did we get here? Well, that was 0.0. Let's write this down here. 0.04801. Because if we're going to find the percentage error, we need obviously this one to compare to the approximate value. So that's the first thing that we need. Obviously, you would have that already because you've got the full working. Because I cleared the screen, I'll just give it there. So now we need to use our approximation here. So if I call it Z now for our approximation here, so Z follows a normal distribution with parameters of the mean, which is 104. And then we've got the standard deviation here of 7.07. Okay, I'm just going to keep it like that. Obviously, when I put it into my calculator in a moment, we'll give it in its exact form, but just so we've got something here, 7.07. So in fact, let me just give that as a variance. So that's the standard deviation. If I square that, that's my variance. So we now need to use the approximation here to find the probability of y being equal to 100. So if we use the approximation here, because this is a normal approximation, we need to apply a continuity correction, okay? So in this case, because we're looking for an exact value, y is equal to 100, when I find the approximation here, so let me just get rid of the equals, this would be an approximation. In fact, let me do it underneath, just so I've got enough room here. So if we do it right to the left, y is equal to 100, would be approximately, the probability of being between 99.5 and 100.5. So what we do, we apply the continuity correction half a unit below and half a unit above. Okay, so basically just subtract 0.5 off 100 and add 0.5 to 100. Okay, in this case here, we're going to get 99.5. And this would be for the variable z here. That's our approximation. And then 100.5. Okay. So from here now, this is nice and straightforward. All we're simply going to do here is use our calculator. So again, we're going to stats mode, distribution. We now want the normal distribution here. So stats mode, distribution, normal. Now in this case here, we already know the lower value and the upper value. So that would be my lower, it would be my upper. Obviously, make sure you're working with NCD here. So NCD here, make sure you're just making a note of this. Make sure you're working with the correct probability here. So in this case here, lower, that's 99.5. Let me just write these down here. So lower, 99.5. My upper value here, that is 100.5. My standard deviation here, sigma, that would be the square root then of 49.92. And then for the mean here, mu, that would be, what did we get originally? 104 here. Perfect. So let me just double check I got the correct standard deviation here, square root 49.92. Yeah, perfect. So now, if I just put all these in myself, so square root 49.92. My mean here is 104. I've got 99.5 as my lower, 100.5 is my upper. If you enter this now into your calculator here, as long as you've obviously entered incorrectly, what you will get then for the probability here, to 5 decimal places, is you get 0.04808 here. Okay, so it's 5 decimal places. 1, 2, 3, 4, 5. Perfect. So we've got the probability here for the approximation. We've got the original probability here for when y is equal to 100 using the binomial distribution. So all that we need to do now is just find the percentage error. So we're nearly there now. Let's just find the percentage error here. So for the percentage error here, we'll see a few different ways you could actually find the percentage error here in terms of the actual calculation. The way that I'm going to do it here, I'm going to do 0.04808 minus this value here, the one that we originally found, 0.04801. 801. And I'm going to divide by, obviously, this true value here. Obviously, you could do this the other way around. That's what I'm kind of referencing there. But you would need to take the absolute value there to ensure that your numerator is positive. But either way, no matter which way you do this, you should get the same percentage error here. Obviously, don't forget that you need to times this then by 100. So times by 100 here. Run out of room a little bit. But what you're going to get then if you do this as a percentage error is 0.15% there. Okay. My percentage error here is pretty small, 0.15%, and there we have it. So that's a solution to C, and that gives the solution there to question 1. If we take a look now at question 2 here, we've got the following table which presents the marks scored by 7 students in maths and physics exams. We can see the table here just down below. So for the first part here, part A, it says state what is measured by the product moment, correlation, coefficient. So for part A then, as we can see here, this is simply 1 mark, so we shouldn't really expect too much work here. And the reason for that is because this is a definition that you just need to remember. What does the PMCC show? Well, the PMCC shows the relationship, which in this case, for this data here, would be a linear relationship, but showing the relationship then between 2 variables. Let me just write that down in full. So the PMCC, that's the product moment correlation coefficient. This shows the relationship which in this case, like we said, this is a linear relationship. Put that in brackets between two variables. Okay, and that's all we simply need there for the first part, so that's between two variables. I guess is the first mark to begin with. So for part B then, it now asks us to find the product moment correlation coefficient for these data, giving your answer to 3 decimal places. So again, this is just 1 mark, so we shouldn't really expect too much work here. And the reason that's only 1 mark is because we're going to use our calculator. So this will differ depending on the type of calculator you're using, whether that's a scientific or a graphical calculator, and the different brands. But if I just go through the way I do it on my calculator here, this might help you. So the first thing that I do is I go into stats mode. So I go into stats mode. First thing that you need to do here, when I go into stats mode, I have a few different options. So the first thing I'm going to click here is calc. I click calc. Once I do that, I get 3 different options in my case. So I get 1 var, 2 var, or reg. I click reg then. This is for regression. I want to do that again. I get a number of different options here. And what I do, or what I click here is X. And once you do this, you're going to get 2 options in my case here. And it doesn't actually matter which of these 2 options you choose. The 2 different options you're going to get here, 2 different options you'll get here are AX plus B, so AX plus B, or you'll get A plus BX. Okay. Like I said, no matter which of these 2 you choose, these would still give you the same product moment correlation coefficient for these data here. Okay, so either of these are absolutely fine. I'm just going to click this one here, but like I said, it really doesn't matter. So when I press that, I get a number of different values here. And the one that you want, the one that gives you the product moment correlation coefficient, is the value of R. In my case here, if you enter the data in correctly, so what you also need to do is enter the data in here as 2 lists. So you'll have list 1 and you'll have list 2. I should have said this before. This is the first thing that you actually need to do here. The list 1, enter in, say, the math scores here. So you'd have 35, 30, and that would go all the way down to the very last value here, 24. 24 underneath. I'll clear all this in a moment. And then for list 2 here, you'd have 43, 36, all the way down to 28. So again, 43, 36, all the way down, like we said, to the last value here, 28. So as long as you do all that correctly, what you should get then for the value of R here, again, just make sure you give this to the correct accuracy of 3 decimal places, and you'll get 0.645. Okay. And there we have it. So that's all we need there for part B. That gets us the next mark there. And what I'm going to do here, I'm just going to clear the screen. Do take a note of this value here of R. If you don't have it, you will need it for part C. Just clear all that. So for part C then, it says test at the 5% significance level whether there is evidence of a positive correlation between the marks scored in maths and physics. So what do we do here? Well, we're doing a hypothesis test here. We know that because it obviously tells us that we need to test here. We're doing the significance level. So we need our hypotheses here. I need H0 and I need H1. Okay, so that's the first thing we should do here for a hypothesis test. So because we're testing for the correlation here, in this case, we're testing for evidence of a positive correlation. And don't forget, when you're testing for correlation here, the variable that we use is the Greek letter rho. The rho is kind of like a slanted P here, if you can't remember what this looks like. Something like that. Then again here for H1. So for H0 then, we're testing whether the PMCC, the correlation here is equal to 0. And then in H1, we're now testing what we're asking for here. So whether there is evidence of a positive correlation, that would be rho being greater than 0. Okay, like so. So now we've got the hypotheses here. What we also know is R. That would be our test statistic here. So R, which is equal to the test statistic, a mouthful, and that is equal, like we said in part B then, that was R, which was 0.645 there. 0.645. And what we also need here is the critical value, so which we can compare the value here for R, or the test statistic, against. So we need the critical value. Now, to find the critical value here, you do need to use your formula book. Okay, so in that case, then you're going to use your formula book here. Don't forget you need N. So n is the sample size, which in this case is simply 7. So for part C then, n would be equal to 7. Now this is a one-tailed hypothesis test because we're testing whether this is greater than 0. You don't need to divide the significance level by 2 to make sure you're using the correct significance level here. It would be 0.05, 0.05. So in this case then, the critical value here, as long as you look this up correctly, this would be 0.6694. Okay. So what I need to do now is compare this value here of R, which is our test statistic, against the critical value. So because 0.645 is less than this value here, the critical value, this tells us now that we need to accept H0. Okay. We accept H0 here. The way that you decide here, so if the value here for R and your test statistic is less than the critical value, you accept H0, which is what we've got here. If it was larger than the critical value, then we would reject H0. Okay. We accept H0, and all we say here is we have insufficient evidence. At the 5% significance level. I'm just going to write this down in full. To suggest a positive correlation between maths and physics. Okay, so to suggest a positive correlation between maths and physics there. Okay. Now it is important to state here that you do need to give this conclusion here. We can't just say accept H0. You need to actually specify then in context what we are basically saying. So we're saying that we accept H0 because we have insufficient evidence at the 5% significance level to suggest a positive correlation between maths and physics. Okay. And there we have it. So that gets us the 3 marks there for part C. And that gives us the solution there to question 2. If we take a look now at question 3 here, we've got the events P and Q which are given in the Venn diagram below. We're also told that X, Y, 0.2 and 0.24 are all probabilities. So for the first part then, part A, we're asked to find an expression in terms of Y for these 2 different probabilities here. So I'm going to do both of these here in a different colour. So for the first one then, looking at the probability of Q. So for the probability of Q here, that would simply be the sum of the 2 probabilities here that fall inside the event Q. That would be 0.2 plus Y. 0.2 plus Y there. So hopefully nice and straightforward. Then we'll do the second one here. Let's do it in green. So for the second part here, we're looking for the probability of P given Q. This one here now involves conditional probability. So in that case, we need to restrict the sample space here. And in this case, because we're conditioning on Q, we restrict the sample space then to Q. So if I just go around this here in green pen, restricting this now to the sample space here, or restricting my sample space here then to the event Q. So where does P fall inside Q here? That would be this intersection here, the overlap. That would leave me with 0.2. What is this out of? Well, that would be the sum of these probabilities here inside Q. So it would be 0.2 plus Y there. Okay. And there we have it. So that's the solution to the second part there. And that gives us the solution to part A. So now I do the second part here, part B. We'll do this in a different color again. So now we're looking for an expression in terms of X and Y for the probability then of P union Q. So for P union Q here, that would be everything inside both of these circles here. Let's go around here. Like I said, everything inside both of these circles. So in this case here, that would simply be X plus 0.2 plus Y. for P union Q here, obviously that would be X plus 0.2 plus Y there. Okay. And there we have it. So that's the solution to B. Just one mark there. That you can see, you shouldn't really expect too much work there. It is just one mark, so do use the marks as a guide. That's part B. And then finally, I'll go back to my original pen colour here then for C. We're given that the probability of Q here is equal to 3 times the probability of P. Find the value of X and Y. So let's just begin here by finding the probability then of Q and the probability of P. So we already know the probability of Q. Like we saw, that was 0.2 plus Y. The probability of P then, that would simply be X plus 0.2, or 0.2 plus X. So let's just do it that way around, since we did it for the probability of Q. Okay. So in this case then, if the probability of Q is equal to 3 times the probability of P, then what I can see here is 0.2 plus Y is equal to 3 lots of this probability here. Okay. So what I'm going to do here now is expand the right hand side here, this single bracket. So obviously the left hand side won't change. 0.2 plus Y. That's equal then to 3 times 0.2, so that's 0.6. Plus 3x, so 3 times x gives me 3x. So here, it's up to you now which variable you rearrange for. What I'm going to do here is I'm going to rearrange and make y the subject, seeing as obviously y is just single, it's just y on its own rather than 3x. Obviously, if I rearrange and make x subject, I need to divide by 3. And it makes life a little bit trickier. So you can do it by rearranging and making x a subject, but I wouldn't advise it for this example here. Okay, so making y the subject now, we'll try 0.2 off both sides. And therefore, y is equal to 0.4 plus 3x. Okay. So y is equal then to 0.4 plus 3x. And what we also know here is that some of these probabilities would be equal to 1. Okay, so the sum of the probabilities here is equal to 1. I'm not sure quite whether I spelled that correctly, but we'll go with it. So the sum of the probabilities here is equal to 1. So in that case then, what we're saying is x plus y plus 0.2 plus 0.24 here, that would be equal to 1. Let me just write that down here. So x plus y plus 0.2 plus 0.24, that would be equal to 1. So from here then, 0.2 plus 0.24, that's 0.44. So obviously I can subtract that then off both sides. So I get x plus y. So x plus y is equal to 1 minus 0.44, giving me 0.56 there. Okay. And we're getting pretty close to the solution here. Now we just need to keep going. Now, obviously I've got an expression here for y. So y is equal to 0.4 plus 3x. So I'm going to now substitute that into this equation here. I call this equation 1. So therefore, what I'm going to actually quickly do here is just clear a bit of room at the top. Let's get rid of this at the top here, just so I've got enough room to finish off. Don't need too much more here. So we just go to the top here. So like I said, I'm going to now substitute y into equation 1 here. So I've got x plus 0.4 plus 3x. So x plus 0.4 plus 3x. Have I done this correctly? Yeah, and that's equal to 0.56. Okay, so all I've done here is simply replace y then with this equation here. So x plus 0.4 plus 3x is equal to 0.56. So now what I've got here is just an equation in terms of x, so we can now solve for x here. So x plus 3x, that's 4x. I'm also going to subtract 0.4 off both sides here, so 0.56 minus 0.4, that gives me 0.16 there. And then finally, if I divide both sides here now by 4, I get x on its own. So x equal to 0.16 divided by 4, giving me 0.04 there. Okay, so that's the value of x. So now we just need the value of y here. And in this case, because we've already got this equation here, y equals 0.4 plus 3x, we can now find the value of y. If I substitute x equals 0.04 in, y is equal to 0.4 plus 3 times 0.04. In that case, I get y is equal to 0.4 plus 0.12, giving me 0.52 there. Okay, and there we have it. So that's the value of x, 0.04, and the value of y, 0.52 there. Okay, and there we have it. So that's the solution to C, and that gives the solution there to question 3. Moving on to question 4 now. So we've got a teacher here who records a number of hours that students are revising for their upcoming maths exam using their online learning system. The teacher chooses the first 50 names that appear on the online learning system to form his sample. The results are presented in the table below. So what we can see here, we've got the hours spent revising, which is modeled as H, or we're using H here just to represent that. You can see the different classes here. Then we've got the frequency, so this is the number of students. So obviously this should add to 50 here. Okay. So for the first part then, part A, we have to name the sampling method that the teacher has used. In this case, you just need to recognize what sampling method the teacher has used. If you just chose the first 50 names that appear, this would be a convenience sample or convenience sampling method. So in this case, I just chose the first 50 names that appear. This is convenience sampling. Okay, just one mark for that. Nothing, not too much work there really for convenience sampling. That's the first part there, part A. So for part B now, it says briefly explain with a reason whether the hour spent revising H is a continuous or discrete variable. So in this case here, H is looking at time, so it's hours spent revising. And remember that time is a continuous variable. Okay, if you do struggle to remember which way this kind of goes, whether it's going to be discrete or continuous, remember something discrete or something that is discrete is something that you can count. So for example, the number of pens on my desk, for example, that would be a discrete variable. I can't keep breaking that down. So for example, with time, you can keep breaking that down. For example, you've got hours, you can break that down then into minutes, you can then break that down into seconds, for example. That would be continuous, but the number of pens, I can't break that down anymore. I've just got a fixed number of pens on my desk, for example. So in this case here, H is continuous. Okay. And there we have it. So that's part B again, just another one mark there, not too much work. So for part C now, it says give 2 reasons why a histogram could be used to model the data. So if we just take a look at the table here, why can we use a histogram to model this data? Well, there's 2 reasons here that we can use a histogram. So we know that the time here, H, is continuous. So looking at continuous data basically. So how should I word this? Time /H, that's the variable that we're using here, is continuous. And then my other reason here is because it's in a grouped frequency table. And we use histograms to represent grouped frequency data like this. So, and the data is in a grouped frequency table. Okay. And there we have it. So that's part C there. And then finally for part D here, it says use your calculator to find estimates for the mean and standard deviation of the hours spent revising. So you just need to use your calculator here. And what I'm obviously looking to do here now is find the mean and standard deviation for grouped frequency data like this. So how do we do this using our calculator? Well, the first thing you need to do is go into stats mode. And when I go into stats mode, I get a number of different lists here. So I've got list 1, list 2, list 3, list 4, and so on. So what we need here is 2 lists. I need list 1. And I also need, in fact, let me just do a line here just to break this up. And then I need list 2. So in list 1 here, what I'm going to do is, because we've got group frequency data, I need the midpoints. Okay, so I need the midpoints here for each of these class intervals. So my first midpoint here, don't forget you can just add these 2 bounds together, divide it by 2, so that would be 3. This one here would be 7.5. This one here would be 12.5. This one here would be 17.5. And then finally, 22.5 here. Okay. So that gives me the midpoints there. So what I'm going to do here for this one is put all these midpoints in. So I'd have 3, 7.5, 12.5, 17.5, and then finally 22.5. And then in list 2 here, what I do now is I put the frequencies here. So make sure you actually match these up correctly. So the 3 here, this midpoint here should go with the 9, this frequency of 9. Then we've got 14, 25, and 2. So 14, 25, and 2 there. Okay. So from here then, we're pretty much done now. All I need to do now is just basically go on to Calc. I click Calc here. And then once you click Calc, I can have 1 var, 2 var, regression. So what I need here is 1 var, but we can't just click that yet. I need to go into Set or Settings here. So we then go into Settings. And what you need to do here now is change the 1 var frequency to be list 2. Okay. If you don't do this, you're going to get the incorrect estimate here for the mean and standard deviation. Okay. So in that case then, you just press enter now, click 1 var, and this will give you the estimates that we need here. So in this case here, let's do it underneath, we've got about enough room. So X bar, that's my estimate here for the mean of this group frequency data. That would be 10.29. 10.29 there. And then finally, the estimate here for the standard deviation. So there's going to be 2 values here that are very close. The one that you actually want here is sigma x. Okay, that's the one that you want here. So in this case here, this would be 4.986. So if I do that save to 3 significant figures here, as I call it sigma, that'll be 4.99 there. Okay, and that's 2 free significant figures there. And there we have it. So that gives the solution to D and the solution to question 4. Moving on to question 5 now. So we've got the discrete random variable x, which has the following probability distribution. We can see the probability distribution here in the form of a table. Okay. We're told that k is a constant, and for the first part then we have to show that k is equal to 180 divided by 137. So for the first part then, part A, how do we find the value of k? Well, what you should be aware of here is these individual values are all probabilities. If I add all of these probabilities up here, that would be equal to 1. What we're saying then is the sum of these probabilities here, the random variable x, that will be equal to 1. Okay, so if I add k over 3, k over 6, k over 9, k over 12, and k over 15 together, that would be equal to 1. Let's just show that here. So k over 3 plus k over 6 plus k over 9 plus k over 12, and then finally k over 15. The sum of these probabilities here would be equal to 1. Okay. So the first thing that I'm going to do here now is factor the k out. In that case here, I'm going to get k times 1 over 3 plus 1 over 6 plus 1 over 9, and so on. 1 over 3 plus 1 over 6, 1 over 9, 1 over 12, and then finally 1 over 15. Okay, and again, that's all equal to 1. So from here now, what I'm going to do is I'm going to evaluate this bracket here. And to do that, you can just simply use your calculator. You don't have to do this by hand or anything like that. So what I've got then is 1 over 3 plus 1 over 6 plus 1 over 9. So I'm just quickly do that here. So 1 over 9 plus 1 over 12. And then finally plus 1 over 15. What you'll get here, if I give this in its exact form, is I get k times 137 over 180. If you add all of these fractions here together, you get 137 over 180, and that's all equal to 1 here. So k times this bracket here, which is 137 over 180, that's equal to 1. So finally here, if I just want the value of k, here, we need to simply divide both sides by 137 over 180. So k is equal to 1 divided by 137 over 180, which in this case would give us what we need. So that would be 180 over 137 there. Okay, so as required, giving us a solution to part A. That's part A done. Let's move on to part B now. With part B here, this is a question dealing now with probabilities here for this discrete random variable x. So we have to find two probabilities here. So for the first one then, we're looking for the probability of our random variable x being greater than or equal to 80. So what values here in this table satisfy this probability? So there's two possible options here. We can have 80 here when little x equal to 80, when little x equal to 100. Okay, so with the probability x equal to 80 plus the probability x equal to 100. Okay, so because these are already in terms of k here, we do know the value of k, so that's fine. But what I'll do, I'll just give these probabilities here in terms of k, and then obviously I'll just substitute the value of k in later on to find the value. Okay, so the probability. The probability of x being equal to 80, that's k over 12. Got k over 12. We've then got the probability here of x being equal to 100, so that's k over 15. So if you evaluate this here, what this would give me is k times 3 over 20. So k times 3 over 20. And we know the value of k. K is 180 over 137. So I just quickly do this on my calculator here. So 180 over 30, 100, well, try again. 180 over 137 times that now by 3 over 20. And what I get here then is for this probability here, this is equal to 27 over 137 there. Okay, so 27 over 137, so that's the first probability there. And then for the second part here, again, nice and easy. The probability that x equal to 10. So this isn't a trick question. If you look at the probability distribution here, obviously 10 doesn't appear here inside my probability distribution. But in that case, in the probability here that x equal to 10, that would simply be 0. Okay, so for B, probability that x equal to 10, that is equal to 0. Okay, so it falls outside this probability distribution here. But in that case, then the probability that x equal to 10 would be 0. Okay, so that's the solution to B. We're going to need to clear the screen here to have a go at part C and part D. So for part C then, what we're given here is another discrete random variable. So we've now got the discrete random variable y, and that has the following probability distribution where a is a constant. So we've got the distribution here. So for the first part here, part C, we have to determine the range of possible values for a. So how do we determine the range of possible values for a here? Well, we need to just basically break down each individual probability. So all of these values here, so 3a, 0.2 minus a, and 0.8 minus 2a, they are probabilities, right? So they must be greater than or equal to 0. So probabilities are greater than or equal to 0. Make a note of this here. The probabilities are greater than or equal to 0. Sounds basic and sounds obvious, but it is an important point and it will help us determine the range of possible values here. So in that case then, 3a must be greater than or equal to 0. So in that case then, a must simply be greater than or equal to 0. So that's for the first probability. Well, that's not our solution. We need to consider each individual probability here. Let's just split this off now into 3 sections. So for the next one then, we've got 0.2 minus a. So again, that must be greater than or equal to 0. 0.2 minus a here, and like we said, that would be greater than or equal to 0. So here now we solve this inequality. I get 0.2 greater than or equal to a. So if 0.2 is greater than or equal to a, that's the same as a being less than or equal to 0.2. So a is less than or equal to 0.2. And then again, just one more probability to consider here. We've got 0.8 minus 2a. 0.8 minus 2a, and again, this must be greater than or equal to 0. So add 2a to both sides here. I've got 0.8 is greater than or equal to 2a. And I divide both sides by 2 here, so I get 0.4 is greater than or equal to a. If 0.4 is greater than or equal to a, that is the same as a being less than or equal to 0.4. Okay. Now that we've considered all three individual probabilities here, we can now determine the range of possible values for a. In this case here, we can see three inequalities here. So a must be greater than or equal to 0, so that's fine. And with this one here, we're restricting this, so a must be now less than or equal to 0.2, and then for this one here, a must be less than or equal to 0.4. So in this case, if you consider these inequalities, then in this case, a must be between 0 and 0.2. Okay, so therefore, we are between 0 and 0.2. Okay, and there we have it. So that's the solution to part C. I guess is the next 2 marks. And then finally, we arrive at the very last part of this question here, part D. We've got 5 marks for this part here, so quite a bit of work here. So we've got the random variables y1 and y2. We're told that they have the same distribution as y, and they're independent of each other. We're asked to show that a simplified expression for the probability of y1 being equal to y2 can be expressed in terms of a as this quadratic here. So, where do we begin here? Kind of just drops into this part here, and then just given this quadratic. So, I think probably the trickiest part of this question is just kind of knowing where to begin. So, if you just think about these two random variables here, y1 and y2. If we're looking for the probability that they're equal to each other, so if you think about this here, we could have, say, y1 takes a little value of y here of 1, and y2 takes a little value here of y being 2. Okay, they wouldn't be equal. Okay, so in that case, y2 would be greater than y1. So for the probability of y1 to be equal to y2, they must both take the same value. That sounds kind of obvious, but that's what we're basically aiming for here. So for the probability then of y1 being equal to y2, like we said, we just need y1 and y2 to both be, for example, 1, both to be 2, and both to be 3. Okay, so my 3 options here, I should say, be 1, 1. We'd have 2, 2. And then finally, we'd have 3, 3. Okay. If we get 1, 1, what we're doing here is we're multiplying these probabilities together now. Okay, so 1, 1, I said that would be 3a times by 3a again. So this here, this is 3a times by itself again. So 3a squared in other words. So 3a times 3a, that would give me 9a squared. Okay, that's the first one dealt with. Let's take a look now at 2, 2 here. So same idea again. So the probability of 2 here, that's 0.2 minus a. So it's going to be 0.2 minus a times by 0.2 minus a. If we expand these double brackets here, I get 0.2 times 0.2, so that gives me 0.04. I then got 0.2 times minus a, so that gives me minus 0.2a. Same again here, minus a times 0.2, minus 0.2a. And then finally, minus a times minus a, that gives me plus a squared. If I simplify this here, I'm going to get a squared. I get minus 0.4a. And then finally, 0.04. And unfortunately, we run out a little bit of room here. So let's do 3, 3 over here. So we'll do it underneath this part here. So we'll just cross this out. Continue part D underneath here. So with 3, 3, that would be 0.8 minus 2a times by itself again. Just write the brackets out here. Times by itself again. So now if we expand these double brackets here, 0.8 times 0.8, that will give me 0.64. We've then got 0.8 times minus 2a, that would give me minus 1.6a. We get minus 1.6a. Then again here, minus 2a times 0.8, minus 1.6a. And then finally, minus 2a times minus 2a, that gives me plus 4a squared. Okay. So if we simplify all this here, go underneath, I'm going to get 4a squared. Get 4a squared minus 3.28. And then finally 0.64. Okay. So we're nearly there now. All I need to do now is add all of this together. So the probability that y1 is equal to y2, we can express in terms of a by adding all of these together here. So what have we got here? We've got 9a squared. I've got a squared here and 4a squared. So let me just put all the a squared terms together. That's 4a squared. What else have we got here then? So I put all the a terms together here. I've got no a's in this part here. I've got minus 0.4a here. And then I've got minus 3.2a here. And finally, we put the constant terms together. I've got 0.64. And I've got 0.04 here as well. Obviously, you could have just put these three expressions together, add those together. That's fine as well. I've just grouped the like terms together here. So now we add everything together and simplify. 9a squared plus a squared, that would be 10a squared plus the 4a squared there, gives me 14a squared. Perfect. We then got minus 0.48 minus 3.28. So evaluate that, that gives you minus 3.6a, like we need here. So again, that's perfect. And then finally, we've got 0.64 plus 0.04. Add those together and you get 0.68 there. Okay, so 0.68. And there we have it. So that's 14a squared minus 3.68 plus 0.68 as required there. Okay. And there we have it. So that's the solution to part D there. And that gives the solution to question 5. Taking a look now at question 6 here. So we've got a confectionery company which sells tins of chocolate biscuits. The weight of the tins can be shown to follow a normal distribution with a mean of 475 grams and a standard deviation of 4.5 grams. So for the first part here, part A, we're looking for two probabilities. Write down part A. So to begin with here, what I need to do is define a random variable to model this situation. Let's say we've got x here as our random variable. X follows a normal distribution. My parameters here are the mean. So the mean is 475. Then our variance here would be the standard deviation squared. That would be 4.5 squared. Okay, like so. So that's our distribution here that we're working with. So I'm looking for two probabilities now. So for the first one here, we're looking for the probability that our random variable x here is greater than 4a here. Okay. So in this case here, to find this probability, nothing too challenging. All we're going to do is simply use our calculator. So this would, be slightly different depending on your type of calculator and the model of your calculator. On my calculator, to find the probability here for a normal distribution, the first thing that I do is go into stats mode. And once I'm into stats mode, then I click distribution. So on my calculator, that's shortened to DIST. Something like that should get you to the next point here. So distribution. Once you click that, it will give you a list of different distributions here. So obviously we're working with the normal distribution. You want normal. Okay, so I click normal here on mine. That gives me the normal distribution. Once you click that, then you get three options. You get either NPD, NCD, or the inverse normal. Now, obviously, working with the normal distribution here, but you've got to be careful which one you choose. So you don't choose NPD. Remember, this is a continuous distribution, so we can't have exact probabilities. But in this case here, we work with NCD. Okay, and obviously we don't require the use of the inverse normal here for this part, so just NCD. Once you click that, then it would give you a few different choices. So the first thing that will ask for is the type of data. It will either be a list or a variable. In this case here, it's a variable, so make sure you're working with a variable. Then it will ask for the lower, upper, the standard deviation, and the mean. So L for lower, U for upper. We then got sigma here for the standard deviation and mu for the mean. So obviously the standard deviation and the mean, I would hope they're nice and straightforward. They just come from the context of the question. So the mean is 475. And my standard deviation here is 4.5. But for lower and upper, that's a little bit more complicated here. They actually come from the actual probability itself. So So we're looking here for the probability of x being greater than 480. I like to think about this almost in reverse. So if this is a greater than probability like this here, or question, then the value here that we're looking to find the probability of, that's my lower value. So my lower value here is 480. And then for the upper value here, we pick an arbitrarily large value. So that would just be, in my case here, a load of 9s. You don't have to be anything specific, but if you just pick a large enough number so that it always works, you won't have any issues here. Then once you press enter, this would give you this probability here. So in this case here, the probability that I get is 0.133. Okay, and that's the 3 significant figures there. So that's the first part. For the second part here then, I've almost technically given the answer away already. And the reason for that is because when I mentioned about NCD and NPD. So remember, the normal distribution is a continuous distribution. So for that reason, we can't find an exact probability like this here. So what I'm looking for is actually the probability of x being equal to 472. Okay, like so. You can't find exact probabilities like this here when you're working with the normal distribution because it's a continuous distribution. So this probability here will always be equal to 0. It doesn't matter what we change this value here to, whether that's 475, 480, 500, 300. It honestly doesn't matter. It's an exact probability here. The actual probability itself would be always equal to 0. Okay, that's all you simply need to do there. For the second part, so that's a solution to part A. So we might need a bit more room here for part B. So let me just clear the screen to answer part B. So for part B then, we're told that the company has a policy that tins of chocolate biscuits that weigh more than 480 grams are to be classed as a defective product and not sold. So given that a randomly selected tin has a weight which is greater than 478 grams, find the probability that the tin is classed as a defective product. So you might not notice it straight away, but this part here, part B, is a question that involves the use of conditional probability. Remember, if you see something that says given that straight away in a probability question, then it's almost certain that you're going to be using conditional probability. So where do we begin here? Well, what I'm looking for then is the probability that x is greater than 480. We're looking for a defective product, and it will only be defective if it's greater than 480. I'm looking for the probability that x is greater than 480. Given that x is greater than 478. Okay. Like so. That's essentially what I'm looking for here. So how do we find this conditional probability here? Well, if we just break it down then, I'm using the conditional probability formula here, or formula I should say. What I've got then is a fraction. So my numerator here is the intersection of these two events. So I've got the probability of x being greater than 480 with the intersection here of the probability of x being greater than 478. And then we divide this here by what we're conditioning on. So because we're conditioning here on x being greater than 478, I divide this by the probability of x being greater than 478. Okay. So what can often cause issues here is the numerator. It looks a little bit complicated, but honestly, if you think about this logically, it's nothing too challenging. What I'm saying here is the probability that x is greater than 480 and the probability that x is greater than 478. Well, clearly, if we're looking for the probability that x is greater than 480, that also satisfies this probability here. Okay, but obviously it won't be the other way around. If I choose this probability here, then we don't satisfy this probability here. So my numerator can be simplified to simply be the probability of x being greater than 480. What I've got here is the probability that x is greater than 480. And that's all divided then by the probability that x is greater than 478. Okay. The numerator here, don't forget, we've actually already computed this value here, or evaluated this value. And we did that in this part here. So this part here, you still got your solution. You can just put that in straight away for the numerator. So to 3 significant figures, that was 0.133. All we need to do now is evaluate this probability here down below. So again, it'll be almost identical to this first part here. The only thing that will change will be your lower value here. So rather than 480, it would be 478. So let me just quickly do that on my calculator here as well. So the distribution, norm, NCD. Obviously, we just change lower here to be 478. Everything else will remain the same. In this case here, to three significant figures, I get 0.252. 0.252 there. And all you need to do here is just put this fraction here into your calculator. So 0.133 divided by 0.252. If I quickly do that here, divided by 0.252, what I get then is 0.527777, a lot of sevens, and then an 8 at the end. If I give it an exact form, what I get here is 19/36. Okay, so 19/36 there. Okay, so the probability that the tin is classed as a defective product is 19/36. So the probability of defective is equal to 19/36 there. Okay, and there we have it. So that's the solution to part B. And again, part C here, there's a bit more work to this, so I'm going to clear the screen just so we've got enough room to answer part C. So we've cleared the screen there now. Let's have a go at part C. So with part C here, what we've got is a hypothesis test. So if I just read the full part out, I've got a company, or the company suspects the scales weighing the tins of chocolate biscuits is not correctly calibrated, and they decide to purchase some new scales. So the company takes a new sample for the weights of 16 tins of chocolate biscuits using the new scales, and they find that the mean weight of the tins is now 477 grams. I want to test at the 1% significance level whether the mean weight has increased. So this is important here. The fact that it's increased here, this tells us that we're working with a one-tailed hypothesis test. So to begin with here, we've got a hypothesis test, so let's just define the hypotheses here. We've got H0 and H1. So what we're testing for here is the mean of this normal distribution. So we're working with the parameter then of mu for the mean. So mu goes in both of these hypotheses here. So what we're testing against is the original mean here, this 475. Okay, so for H0, this is mu being equal to 475. And then for H1, if we're suspecting that the mean weight has increased, that's what we want to test, then mu is greater than 475. In that case, the mean would have increased, right? If mu is greater than 475, then the mean weight has increased. So now I need to define my distribution here for this hypothesis test. So this is for the new sample here, okay? I'm not technically for the new sample, but we're going to standardize here. So what I mean by that then, let's say we've got n here, this is my normal distribution. So in this case here, my mean is the original mean that we were working with, so the 475. But now what we've got here is my variance, and I divide that by the sample size, which is 16 in this case. We've got 16 tins of chocolate biscuits. So I've got 4.5 squared. That's my original variance. Like we said, we divide this now by 16. Okay. So what I'm going to do now is find a probability here. So we need some probability. And what we do is we use the evidence that we've got here now for this new sample. That was the mean weight here. So the probability here, let's just say it's for x again. And I've got my 477. So what we need to decide then is which way the inequality goes here. So for a one-tailed hypothesis test, it's nice and straightforward. You just copy what we've got for H1. So because it's greater than, we're looking for the probability that x is greater than 477. Okay. So now what I need to do here is use my calculator. So if I go into my stats mode again, we're looking to solve or find this probability here. So distribution, norm, NCD again. So again, we're working with a greater than. So my lower would be 477. My upper would just be a load of 9s again. So obviously we do need to change sigma here now. So sigma, my standard deviation. In this case, if it's right underneath, this would be the square root 4.5 squared over 16. Okay, so make sure you actually take the square root of this. So if you do that here, I'll quickly do that myself. So that's the square root of 4.5 squared divided by 16. What you get here then is 1.125. That's 1.125. For the mean then, that stays as the original mean, so that's 475. Okay, and like we said, your lower then would be 477, up as a load of 9s. And if you press enter then, this gives us our probability here. So the probability that x is greater than 477, that is 0.0377. Okay, so that is 2 free significant figures there. And what we need to do now is compare this probability here to a specific value. And what we compare this to now is the significance level here. So 1%, that would be 0.01. So 0.0377, that is greater than 0.01. So in this case here now, we actually accept H0. So we accept H0. We accept H0 here, and we say that we have insufficient evidence to suggest that the mean weight is increased. So we have insufficient evidence, and we should say really at the 1% significance level. Let's write this down in full. Insufficient evidence at the 1% significance level to suggest the mean weight is increased. Okay, and there we have it. So that's what we need there for part C. Do make sure that when you finish your hypothesis test here, do give this conclusion. Don't just say accept H0 or reject H0. It's important to kind of summarize what we've actually found here. So insufficient evidence at the 1% significance level suggests that the mean weight has increased. Okay, and there we have it. So that's all we need for part C. That gives us the solution there. So question 6. If we take a look now here at question 7, this is the very first question here on section B, which is the mechanics part of this exam. We've been given 3 forces, F1, F2, and F3. We're told that they act on a particle P. We're also told that the particle P is in equilibrium, and F1, F2, and F3 are given here like we can see. And we're told that P and Q are constants, and we have to find the value of P and Q. So for question 7 here, this is quite a nice introductory question here to the mechanics part of the exam. So if the particle P is in equilibrium, we know F1, F2, and F3. And what we should be aware of here is the sum of the I components must be equal to 0, and the sum of the J components, again, must also be equal to 0, because the particle P is in equilibrium. So in that case then, if I add the I components here together, set them equal to 0, we can solve for P. So in that case, I'm going to get P plus 2 plus minus 1. So P plus 2 plus minus 1. That must be equal to 0. So in this case, I'm going to get P plus, so it's 2 plus minus 1, it's the same as 2 minus 1, so I get P plus 1. So P plus 1 is equal to 0. In that case, then we can solve for P here, so P is equal to minus 1. And then if we do the same here for the J components, that allows us then to solve for Q. So in this case, I'm going to get minus 2 plus Q. And then finally plus 5 here. And again, because it's in equilibrium, these would be equal to 0. So minus 2 plus 5, that would be 3. So I get Q plus 3 equal to 0. And again, we can just then simply solve for Q. So subtract 3 off both sides. We get Q equals minus 3 there. Okay. And there we have it. So we find the value of P. P is equal to minus 1. We've also found the value of Q. Q is equal to minus 3. And that gives the solution there to the first question in section B, question 7. If we take a look now at question 8 here, we have a particle P which moves in a horizontal plane. At time t seconds, the position vector of P is r meters relative to a fixed origin O. So r is given by this expression here. We're also told that k is a positive constant, and that when t equals 1, speed of P is 10 meters per second. So for the first part, we want to simply find the value of k. So to begin with, let me just write down this expression here for r. So r is equal, that's kt squared I there. And for the j component, we've got 12t minus 3t squared. Okay. So because we're talking about speed here, so the speed of the particle P here, don't forget that speed is the magnitude of velocity. That would suggest to me that we need the velocity here. Okay. So in this case, because we've got r, if I differentiate r with respect to t, that would give me the velocity. So v here, the velocity, is equal to dr by dt. Okay. So if I just go term by term here, if I differentiate now the kt squared here, that would give me 2kt there. So that's 2kti. And then for the 12t minus 3t squared here, again, just go term by term. So 12t, that would differentiate to give me 12. If I put this in a bracket as well here, I get 12. Then minus 3t squared here, that would be minus 6t. I'll get the j as well. That's the velocity. Now we know that when t equals 1, the speed of p is 10 meters per second. So let's just substitute t equals 1 now. So when t equals 1 here, so in that case then, I'm going to get 2k times 1. So that would just be simply 2ki there. I get 2ki. And then for the j component here, we've got 12 minus 6 times 1. So 12 minus 6 there, so that would give us 6j. Okay. Now, in this case here, like we said, the speed, that's the magnitude of the velocity here. Let's find the magnitude here of v, my velocity. So now, this would be the square root here, so it would be 2kl squared plus 6 squared. And in this case here, this is equal now to the speed. So the speed of p is 10 meters per second. So this is equal to 10. So to get rid of the square root here, I'm going to simply square both sides. So I'm going to get 2kl squared plus 6 squared. And that is equal to 10 squared. So all I've done here is just squared both sides. We'll get rid of the square root here on the left hand side. Obviously on the right hand side, we simply square that. So 2kl squared, that would be 4k squared. 6 squared is 36. And then 10 squared here is 100. So now we can simply solve for k here. So subtract 36 off both sides. So 4k squared is equal to 64. Divide both sides now by 4. We get k squared equals 16. Now in this case here, we normally get two solutions here for k. Obviously you could include the negative solution here. You get positive 4 and negative 4. But because we know that k is a positive constant, in this case we can negate the negative solution. So in that case then, k is equal to 4 there. Okay. So that's a solution to a. So we find the value of k there. So k is equal to 4. Okay, so that's part A done. Now let's take a look at part B over here. We should have enough room for this. Only 2 marks for part B. So for part B, it says show that the acceleration of p is constant. So here what we've got is the velocity. So what did we get here? We had 2k ti plus 12 minus 6tj. So rather than writing that with the k involved here, we know that k is 4. So let's just rewrite the velocity then. So v is equal to 2k ti. We know that k is 4. So 2 times 4 there. So I get 8ti. So 8ti there. And then we've got 12 minus 6tj. 12 minus 6tj there. So remember, if we keep going down now, so we start with our displacement, then we have velocity, and then we have acceleration. So to go down here, we differentiate with respect to t, so d by dt. If you want to go the other way, so you want to go up here. So for example, if you have the acceleration, you want the velocity, you need to integrate here with respect to t. Okay. Obviously, if I've got the velocity here and I want the acceleration, we need to differentiate v in this case with respect to t. So a is equal to dv by dt. If we differentiate here with respect to t, so again, just going term by term here, 8t, that would differentiate to 8, so I get 8i there. Doing the same now with the j component here, the 12, that would differentiate to 0 because that's a constant. And then minus 6t here, that would differentiate to give me minus 6. So we get 8i minus 6j there. Okay. And then we're pretty much done here. So you just need to explain now why the acceleration of p here is constant. So the reason that this is constant here is because a does not depend on t. So because there's no t involved here, not dependent on time, so it's not dependent on t. In that case, a is a constant. Okay, or a is constant, I should say. So a does not depend on t. A does not depend on t, so therefore A is constant. Okay. And there we have it. So that's all we need to show for part B. So obviously, if you've got the velocity, you know, the acceleration, we need to differentiate v there. With respect to t, we get 8i minus 6j, and because there's no t involved, a is constant. Okay? And there we have it. So that's the solution to B and the solution to question 8 there. If we take a look here at question 9, we've got a uniform rod AB of mass 3 kilograms is freely hinged at one end A to a vertical wall. The beam is held in equilibrium by a rope that is attached to a point C on the beam, where the length of AC is 0.2 meters. And we can see that here in figure 1. Okay. So the rope is attached to the wall at the point D, which is vertically above A, and the beam is modelled as a uniform rod, and the rope is modelled as a light, inextensible string. Now we're also told that the tension in the rope is 60 newtons. So for the first part then, part A, we have to find the distance from A to B. So how do we do this here? Well, the very first thing that I do here is just actually label this diagram, okay, and add the extra forces that we know. So this is a uniform rod AB of mass 3 kilograms. So exactly halfway, the halfway point on this rod, okay, that would be the center of mass. Okay, so I can't get it exact, but let's just say it's roughly here. That would be 3g here. Okay, so it's 3 kilograms, that would be 3g. Okay, what I'm also going to do here is label the distance then from A to the center of mass here as d. Okay, we'll label that as a length here of d. Okay, we also know the tension here, so the tension in the rope is 60 newtons, so I'm also going to add that to my diagram here. That would be 60 newtons there. Okay, so I think we've got everything that we need here now. So to begin with here, what we're going to do is we're going to take moments. I'm going to take moments about A. So this is for part A. If I take moments about A here, moments about A, then obviously let's just assign a direction here to be positive. So I'm going to take moments here for A, it's being positive going counterclockwise or anti-clockwise here, this way. So in this case here then, what I'm going to get is 60 sine 45. My angle here is 45 degrees, so I'm going to get 60 sine 45. That would be positive. And don't forget we need to times that by the distance here from A to C. Okay, so that would be 0.2. So we get 60 sine 45. And then we times it by the distance here, which is 0.2. Okay, and that would be positive here if you think about, if you were to, I like to think about is if you had your finger here, okay, and you was holding this like ruler, and you was to push up at this point here, C, what direction would this go? It would turn this way, so it would turn in the direction we've took as positive here. That would be positive as well. So now, what I'm going to get here is this point here. So from A to this point here, well, the force here is 3g, and the distance here is d. If you think about this now, so again, my finger's here at A, that's where we're taking moments from, but I push down now at this point here, like the force shows, obviously it would go in the opposite direction here. Okay, so it would be minus 3g times by the distance here of d. Because it's in equilibrium, this would be equal to 0. Okay, so what I'm going to do now is hit the 3gd over to the other side. I get 60 sine 45 times by 0.2, and that is equal to 3gd there. So now if I evaluate the left-hand side here, well, sine of 45, that's 1 over the square root of 2. I get 60 over the square root of 2. Then we times that by 1/5 here, like so. And that's equal to 3gd. Okay. So if I keep simplifying the left-hand side here, this is the same then as 60 over 5 root 2. And that's equal to 3gd. So from here now, we can solve for d. So I'm going to divide both sides by 3g. So we haven't got a value here specified for g, so I'm going to take g then as 9.8. Okay. I'm going to divide now by 3g. So 60 over 5 root 2. If I divide by 3g, then that's the same as times by 1 over 3g. Just to make sure my left-hand side looks a little bit neater here, rather than having a fraction, dividing them by another number here. That's going to be equal to d. So you can either just put 60 over 5 root 2 in your calculator and then divide that by 3g, so 3 times 9.8, that's fine. Or just times it by 1 over 3 times 9.8. Either way, that's absolutely fine. But what you should get here for d then, you should get that d is equal to 0.29, okay? 0.29 here. So in this case here then, what I found is the length here from A to the center of mass, that is 0.29 units. Or it would be in this case 0.29 meters. So the actual length then of the rod AB, if you think about this here, because this is the center of mass, it was exactly halfway between A and B here, it's the halfway point, then I just need to double this length here. So from here to here, that would also be D as well. Okay, so in that case then, the distance from A to B, so AB is equal to 2D. That's 2 times 0.29, and that gives us 0.58 meters there. Okay, and there we have it. So that's the first 5 marks there for part A. So now let's take a look here at part B, and we should have enough room to do this underneath here. It says find the magnitude of the resultant reaction of the hinge on the beam at A. So all I'm going to do here now is just resolve horizontally, resolve vertically, and then take the magnitude. So if we start by resolving horizontally, resolve horizontally, and what do I get here? So in this case here, I'll call it RH for example, this would then be 60, tension here, 60 cosine 45 this time, so 60 cos 45. So that was all we get here resolving horizontally. So in this case here, if I just simplify this, cos 45, that's also 1 over square root of 2. I get 60 over the square root of 2. So there we've resolved horizontally, nice and straightforward. And what we're also going to do here now is resolve vertically. So resolve vertically. In this case here, if I call this RV, then what I'm going to get here is I'm going to get 60 sine 45. Going this way now, resolving vertically, so I get 60 sine 45. And opposing this here, then we have the 3g here. So that's in the opposite direction. If I take up as positive, I should have actually assigned what I was taking as positive here. So if up is positive, I get 60 sine 45 minus 3g there. Okay. So obviously this will be a decimal here. If you put this into your calculator, what you should get here then is 13.026 newtons there. It goes on for a little bit more, but if I just round it to that degree of accuracy there. And then we're nearly done here. All I need to do now is find the magnitude. So the magnitude here, we just apply Pythagoras. So the magnitude here now, we take the square root of this squared plus this squared here. That's 60 with the square root of 2, in a bracket here. So that's squared plus 13.026 all squared. Okay. So you need to do now is put all this into your calculator here. Obviously make sure you do 60 over the square root of 2 squared plus 13.026 squared. Take the square root. So I'm going to quickly do that here just to make sure I get the same. So 60 over the square root of 2, I square that, plus 13.026 squared, and take the square root of this, and you get 44. If I round it to one decimal place, I get 44.4 there. And this would be newtons. Okay, so this is the magnitude of the resultant reaction of the hinge on the beam at A. So I get 44.4 newtons there. Okay, and there we have it. So that's the solution to B and the solution to question 9. Tail up note question 10 here. So we've got a particle P which is projected from a point O with speed U at an angle theta above the horizontal. At the instant when the horizontal distance of the particle P from O is x, the vertical distance of the particle P above the ground is y. So the motion of the particle P is modelled as that of a particle moving freely under gravity. This is a show that part to begin with here. So part A is show that. We want to show that y is equal to x tan theta minus gx squared over 2u squared times 1 plus tan squared theta. And hopefully you might actually recognize this equation here. And the reason for that is because this is one of the projectile motion formulae. So how do we actually derive this result here? Well, the first thing that I do here is just draw a small diagram just so we can kind of illustrate this problem. That's my y-axis here. I've then got my x-axis here. It's projected from a point O. We have speed u and angle theta above the horizontal. This will look, say, something like this here. That would be with speed u. My angle here is theta, so this is theta above the horizontal. Let's say like so. So what we're saying here then, if I had to draw the curve as well, we'll have, say, something like this here, okay? And what we're saying then is for the horizontal distance here of the particle P from O, we can record that as x. Let's say x there. And the vertical distance of the particle P above the ground is y. This point here, that's height of y, okay? So what I'm going to do here now to begin with is just split this into components. So if I use a different pen color here, just to highlight the components, what we've got here is a horizontal component and a vertical component. So for the horizontal component here, this actually involves the angle theta here. If it involves the angle theta, then this would be in terms of cosine. So we've got the initial speed here, speed u. But what I've got here then for my component is u cos theta, this angle here. And then for the vertical component, this in orange, what I've got here then is u. So we've got u again here, but this time it would be sine theta. So I've got u sine theta. Okay, that gives me my two components there. What I'm going to do now to begin with here is just start by resolving forces. So go back to my original pen color. So let's start by resolving here horizontally. If I take this direction here to be positive, then in this case here, what I'm looking at is the displacement. And remember, displacement is equal to velocity multiplied by time. So displacement that is equal to velocity times by time. Okay, so we can simplify that result. That would obviously just be S is equal to Vt. But in this case here, what we can see then is that X would be equal to V. That would be u cos theta. And then we times that by the time here, which is just simply t. Okay, so in that case then, X here, my displacement, that would be X here, that is equal to V, like we said, which is u cos theta multiplied by the time here, which is t. Okay, so that's my first force resolve there. Now let's consider vertical, so resolving vertically here. I've got R upwards, so I take upwards as being positive here. Now we need the next equation here, and this one's a little bit more complicated to kind of derive. So to derive this one here, we're actually going to use SUVAT. If I use SUVAT here, I've got S, U, V, A, and T then. So what do we actually know here? So S, in this case, my vertical displacement now, that would be Y units, so Y units up. We take Y there for displacement. U then, that would be u sine theta. So u sine theta. V here we don't know, so we leave that blank. A then, this would be minus g. Remember, we took positive as being upwards, so gravity acts in the opposite direction here. So that would be minus g. And the time here again, we don't have a specific time. We're just going to say that the time here t is simply t. Okay. So if I put all of that together here then, the equation that we need to use here is S equals ut plus a half at squared there. Okay. So if I put everything together here then, using my SUVAT equation here, or my definition for SUVAT, I guess if you want to call it that, we know that S equal to Y, so I get Y is equal to ut. So u is u sine theta. times by t here, which is simply t. We then got plus a half times by a times by t squared. Well, a is minus g. So what I get here is minus a half g times by t squared. Again, we don't know what t is. That's just simply t. So minus a half g t squared. Okay. What I'm going to do now is I'm going to call this here equation 1. I'm going to call this here equation 2. Okay. So what we need to do now is eliminate t here. So what I'm going to do then is rewrite equation 1 here. So if I do it underneath, let's do it in, say, blue. Then if I make t the subject here, what I'm going to get then is t equals x divided by u cos theta. So t is equal to x over u cos theta. Okay, let's call that equation 3. Let me just get rid of the SUVAT here, just so that doesn't cause any confusion. And we've resolved already. That was over here. So, oops, let's go back to my original pen color here. We've got equation 3 here now. So that's in terms of t here. And what I'm going to do now is sub that into equation 2. So sub into equation 2. In that case then, what I've got here is y equals u sine theta times by t, but we know that t is equal to x over u cos theta. We times that by x over u cos theta. We then got minus a half here. I've got minus a half g times by t squared. So t is x over u cos theta. That would be x over u cos theta all squared. Okay. So let's keep going here. This does feel like quite a bit of work here just for the 6 marks. But, you know, standard wise, there's nothing I don't think too challenging here. It's just going step by step. So let's just keep going here with the simplification. So what I'm going to get then is u sine theta times by x over u cos theta. So the u's would cancel here, like so. But what I get here then is x times sine theta over cos theta. Well, sine theta over cos theta, you should recognize that identity. That would simply be tan theta. So that gives me x tan theta there. So x tan theta. And that's promising. Notice we get that here at the beginning, so that's good. We then got minus a half g times by x over u cos theta all squared. So this bit here, we get minus a half g. I'm going to again get x squared. I'm going to get u squared over cos squared theta. So I'm running out of room a little bit here, so it's a little bit messy. Hopefully you can still see here. I've just squared both the numerator and the denominator here. So I get x squared over u squared times cos squared theta. And we need to keep going here basically. We're going to get it into this form here in a moment. So what am I going to do here? I'm going to pull out here the x squared outside here. So I'm going to get minus a half gx squared. If it helps as well, what I'm going to do is write it in this form here. So I'll kind of run out of room a little bit, but let's kind of take it over here. I've got x tan theta. Like I said, now we're going to apply the x squared here. So it would be 1 over u squared cos squared theta. If I apply the u squared as well here, what I'm going to get then is minus gx squared. I'm going to get minus gx squared over 2 u squared, and then I'm going to times this by 1 over cos squared theta. But remember, 1 over cos squared theta, that is the same as sec squared theta. We times this by sec squared theta. But remember here, sec squared theta, we know the trig identity for that. We'll do it over here. Sec squared theta, that is identical to 1 plus tan squared theta. Okay, so sec squared theta is identical to 1 plus tan squared theta. I can simply replace now sec squared theta with 1 plus tan squared theta. And notice this would give me the result that we need here. So therefore, y is equal to x tan theta minus gx squared over 2 u squared We times that by 1 plus tan squared theta. Okay, and there we have it. So that gives exactly what we needed there for part A, so that is as required. And there we have it. So that's the first 6 marks there, part A done. So you aren't expected to memorize these results. It's important to state this. You're not expected to memorize these results, but you are expected to be able to derive these results. And you know, they're not guaranteed to come up, these you know, derivations, but what I would say, if one does come up, this is probably the most likely. So if you're just going to take a bit of time here just to practice 1 or 2 of these, I would definitely make sure that you're familiar with this one here. That's the first part done there. Let's just clear the screen and have a go at part B. If we now take a look here at part B, it's just important to note here that I have actually changed the question ever so slightly. So for example, the speed here, rather than 10, I've changed that to 12. And then just change the vertical height here to 2.2. So just do take a note of that, just in case you already took note of those values. And just in case you're wondering why that's actually changed, just because there was a few different errors there, just in part B. So let's have a look now at part B here. We have a particle P which is projected from a point O with speed at 12 meters per second at an angle theta above the horizontal. The particle passes through a point M where the horizontal distance from O is recorded as 12 meters and the vertical height above ground is recorded as 2.2 meters. We want to find the 2 possible values of theta, giving our answers to the nearest degree. So to answer part B here, what we're going to do is we're going to use this result here from part A. So for part B then, let's just start by noting the values that we already know from the context of this question here, or this part here. We know U, that's our speed here, which is 12 meters per second. So do it underneath, U is equal to 12. We know X here, that's the horizontal distance from O, so that would be 12. So X equal to 12. We know Y here, so Y is the vertical height above ground, so that's 2.2. And we also know G here, so it doesn't specify a particular value for G. In that case, then we take G to be 9.8. Okay, so we put everything together now. We know Y here, that's 2.2. That's equal to X tan theta, so that's 12 tan theta. We then got minus gx squared over 2u squared, so that's minus 9.8 times 12 squared. That's all divided then by 2 times u squared, so 2 times 12 squared. And we times all of that here by 1 plus tan squared theta. Like so. So now, if we simplified this part here, so let me just use my calculator. I've got 9.8 times 12 squared. Divide that now by 2 times 12 squared. And that gives me 4.9 here. So what I've got then is 2.2 is equal to 12 tan theta minus 4.9 times by 1 plus tan squared theta. So in this case now, if we expand the single bracket here, I get 2.2 is equal to 12 tan theta minus 4.9 minus 4.9 tan squared theta. So what I'm going to obtain here now is a quadratic equation. So if I can set that quadratic equation equal to 0, we can attempt to solve that quadratic equation. So if we make the tan squared term here positive, I'm going to add 4.9 tan squared theta to both sides. We get 4.9 tan squared theta. I've also got the minus 4.9 here, so if I add 4.9 to both sides, I'm going to get 2.2 plus 4.9. That would give me 7.1. I've also got the 12 tan theta, so I'm going to subtract 12 tan theta off both sides. I get minus 12 tan theta. And then, like we said, I get plus 7.1. And that's all equal to 0. So what I've got here now is a quadratic equation. That's in terms of tan theta, and we've set it equal to 0. We want to attempt to solve this quadratic equation here. So there's a number of different ways that you could attempt to solve this quadratic here, whether that would be, for example, using the quadratic formula, or if it's just using your calculator. So that's the method I'm going to use here. I'm going to use my calculator to solve this quadratic equation. I'll set A as 4.9, B here is minus 12, and then C is 7.1. And if you do this here, we get two solutions. So one of my solutions here, this is for tan theta. So I get that tan theta is equal to, let me just check that again. So 71 over 49. I also get that tan theta equal to 1 there. Okay. In this case here now, what we're actually looking for is the possible values of theta. So what I need to do now is take tan inverse of both sides here. In this case here then, theta is equal to tan inverse of 71 over 49. Tan inverse of 71 over 49. So if I quickly do that on my calculator here. Tan inverse of 71 over 49. And then just rounding that to the nearest degree, I get 55 degrees there. 55 degrees. Doing the same here then with tan theta equals 1. Obviously, what I need now is theta. So I get theta here is tan inverse of 1. So tan inverse of 1, that gives me 45 degrees there. So therefore, theta is equal to 45 degrees there. Okay. And there it's like it's the two possible values of theta then. So theta can be 45 degrees and 55 degrees there. And there we have it. So that's the solution to B and the solution to question 10. And finally then, if we take a look here at the very last question on this paper, question 11, we've got some information that's known about two ships traveling at midnight. So at midnight, the ship A is at the point with position vector 3i plus 2j kilometers and is traveling with constant velocity here with minus I plus 7j kilometers per hour. Then at midnight, the ship B is at the point with position vector 6i minus 9j kilometers and is traveling with constant velocity as well, and that's 4i plus 3j kilometers per hour. So for the first part then, part A, we're asked to find the speed of A, giving our answer as a simplified surd. So remember that speed is the magnitude of velocity. So speed is the magnitude of velocity, v. So what I want here is the velocity of A, which we're already given here. It moves with constant velocity, so that's minus I plus 7j, so I need to find the magnitude of minus I plus 7j. For the speed here, that is equal to the square root then, don't forget this is just Pythagoras. It's the square root of minus 1 squared plus 7 squared. We evaluate this here, I'm going to get 1 plus 49. The square root of 1 plus 49, which would give me the square root of 50. Got the square root of 50 there. I want to give the answer here as a simplified surd. So can I simplify this here? Well, yeah, of course we can. So I can write this as the square root of 2 times the square root of 25. And then don't forget the square root of 25 is 5. So I get 5 root 2 there. Okay, so 5 root 2. Careful, not meters per second. This would be kilometers per hour. Kilometers per hour there. Okay. And then we have it. So that's the solution to part A. So that gives us the speed of A. Then for part B here, it says find the bearing at which B is traveling. So I think a little diagram might help here. Let's quickly draw a diagram. That's my J component. This is my I component here. So in this case here, B is traveling then with position vector of 6i minus 9j. So that's 6 units along here, along the I component. Then we go down 9 units here for the J component. So we say here, okay, so that's 6 there across. Then we go down 9. Let's say that's minus 9 there. So what I'm looking for here now is this angle that's formed here. Say that's theta. That's what we're looking for here, okay? Because once I find that, obviously the bearing then would be from here to here. Obviously I'd have to account for this 90 degrees here as well, okay? So in that case then, what I need to do is find theta here. So just using some basic trigonometry then. I've got here tan theta, that would be equal to 9/6 then. So tan theta is equal to 9/6. So obviously if I want theta, that would be tan inverse 9/6. In that case then, theta here is going to be 56.3. 56.3 degrees there. So in that case then, the actual bearing here, so for the bearing here, that would be the original 90 like we said here, plus theta. So theta here is 56.3, so I've got 90 plus 56.3. I add those together here. What I get then is 146 degrees for my bearing. Okay, and there we have it. So that's the solution to B there. So let's just clear the screen here so we've got enough room to have a go at part C then. So for part C then, we're told that the distance between the two ships, T hours after midnight, is d kilometers. So for part C then, we're asked to show that d is equal to the square root of 41t squared plus 118t plus 130. So how do we do this here? Well, what we need to use here, we need to use that we can display the displacement here, r. That would be r0 plus vt. So don't forget r0 here is our original position vector. So the displacement then is equal to the position vector plus the velocity multiplied by time. Okay. In this case here then, I'm going to get two different displacements here. I'm going to get the displacement of the ship A and the displacement of the ship B. Okay, so I've got RA. That models here the displacement of the ship A. So R0, that's my original position vector here, so that's going to be 3i plus 2j. 3i plus 2j. Then I've got the velocity here multiplied by the time. So the velocity here is minus I plus 7j. I get plus minus I plus 7j. Okay, then we times that by the time there, t. Then we're going to do the same here for B. The displacement here, the ship B, RB. I've got my position vector for B, so that's 6i minus 9j. Like so. And then we've got the velocity, which is 4i plus 3j multiplied by the time t. So I've got 4i plus 3j multiplied by t. Okay. And what I'm going to do here, just to make life a little bit easier, I'm going to group the I and the j components for the two individual displacements. So therefore, RA. So if I group the I components here, that would be 3 minus ti. 3 minus ti there. Like you can see here, I've got 3i. I've got minus ti here. So that gives me 3 minus t. And then you factor the I out there. So just grouping the I components, doing the same now with the j components here. That would be plus, and we get brackets here, so it would be 2 plus 7tj there. Like so. Then I've got our B, so again, just grouping the I and the j components here for the displacement for the ship B. In this case here, I'm going to get 6 plus 4t. That's for I. And then for my j components here, I'm going to get 3t minus 9. Okay, like so. Now, what I'm going to do here is, because we're looking at the distance, I'm going to take these as coordinates. Okay, so for A then, my coordinates here would be 3 minus t and 2 plus 7t. So 3 minus t and 2 plus 7t. And then for B here, again, just taking these as my coordinates, I'm going to get 6 plus 4t. And I'm going to get 3t minus 9. Okay, so I've got these coordinates here. So if we're looking for the distance, we need to use the distance formula. So if I write that over here, okay, that d is equal to the square root. This would be x2 minus x1 all squared. x2 minus x1 all squared. And we've got y2 plus y2 minus y1 all squared as well. Okay, so in this case here, it doesn't really matter which way you do this, obviously, because you're squaring it, but if I take this as x2, y2, and this is x1, y1, so we'll just write that above, x1, y1, and x2, y2. Okay. In this case here, then, d is equal. Hopefully we'll have enough room here, but it might be a bit close. I'm going to get 6 plus 4t minus 3 minus t, and that would all be squared. So if we use a square bracket here, just put all that together. So we've got 6 plus 4t. 6 plus 4t minus 3 minus t here. That's all squared. That's x2 minus x1 there. Doing the same now for y2 minus y1. So in this case here, y2 is 3t minus 9. Okay, 3t minus 9 minus y1, which is 2 plus 7t. Okay, that's in square brackets. And again, we square that. So we're getting there now. Let's keep going here. So d would now be equal. Just to save a bit of time here, I've already kind of, evaluated the inside of this bracket here. So all I'm doing here, for example, is 6 minus 3. So it'll be 3. I've got 4t minus t. So just be careful with the signs here. That would be 4 plus 1, giving me 5t there. So I get the square root then. I'm going to get 3 plus 5t to begin with. That would all be squared. So 3 plus 5t all squared. And doing the same here with this part. So I've got 3t minus 7t. So it would be minus 4t. Minus 4t, and then minus 9, minus 2, and that would give me minus 11. And again, that's all squared, so we take the square root of that as well. So all I need to do now, if we're looking for this quadratic here, what I would expect now is once I expand these double brackets here, so this double bracket and this double bracket here, simplify, collect like terms, we should hopefully get this result here. Okay. So let's keep going then. So in this case here, d would now be equal, so I'm going to get 25t squared. I just don't think I'm going to have enough room here, so let me just do it above. Do this over here, at the top over here. So d in this case then, this would be the square root. Like I said, we're going to get 25t squared. So 5t times 5t, 25t squared. I've then got 5t times 3, so that's 15t, but obviously we'll get that again. So 15t plus 15t, that's 30t. And then finally, 3 times 3 is 9 there. I get plus 9. That's the first of the double brackets that are expanded. This is quite a lengthy part C here. So now do the same here with minus 4t, minus 11 all squared. So minus 4t times minus 4t, that would give me 16t squared. Plus 16t squared. Then I've got minus 4t times minus 11. That would be 44t. So I've got 44t, but obviously I would get that again here when you expand these double brackets. So I'm going to get 44t plus 44t. That would be 88t. You get plus 88t there. And then finally, minus 11 times minus 11 is 121. So now the only thing left to do here is just collect like terms. So therefore, d is equal to the square root. I've got 25t squared plus 16t squared. So that would be 41t squared. Then I've got 30t plus 88t here. So that would be 118t. And then finally here, 9 plus 121 will give me 130. I'm taking the square root of that full expression there. And notice I get exactly what we need here as required. Okay, so that's perfect. That's exactly what we needed there. Happy days. So that's a solution to C. And then finally here for part D, it's a hens or otherwise question. So even if you couldn't actually do part C, you can still use this, this working here, this equation for D to answer part C. So I'm going to clear the screen now just so we can have a go at part D then. So for part D then, it says hens or otherwise show that the two ships do not meet with their current motion. So if you think about this equation here, D is the distance between the two ships, okay? That's t hours after midnight. So If the shapes do meet, that would mean not t, but d is equal to 0. So if they meet, and obviously we can see that d would be equal to 0. Okay, so what I'm going to do here is set d equal to 0 now. I get the square root of 41t squared plus 118t plus 130. So now that's equal to 0 because we've set d equal to 0 here. But in this case here now, what I'm going to do is I'm going to square both sides. This will get rid of the square root here. So therefore we get 41t squared plus 118t plus 130. And that would be equal to 0 squared, which obviously is just 0 still. So that doesn't change. And then from here, what I need to show now that the discriminant here would be less than 0. Okay, in other words, there's no solutions here for t. So consider the discriminant now. So delta here equal to b squared minus 4ac. Don't forget this is just the discriminant. So in this case here, delta is equal to b squared, so that's 118 squared, minus 4 times a, which is 41, times by c here, which is 130. I'll just quickly put that into my calculator here. 118 squared minus, so I've got 4 times 41 times 130 there, and I get minus 7,396 there, which is definitely less than 0. So it's a negative number, it's less than 0. In that case here, we have no real solution. So what that shows then, there's no times where these two shapes would meet. Okay, so delta here is less than 0, so the discriminant is less than 0. Therefore, two shapes do not meet. Okay, and there we have it. So that's the solution to D there, and that brings the end of this paper here. So that's the solution to question 11, and like I said, it just brings the end of this paper. So like I said, hopefully you find this paper helpful. It did include both parts here. So the first half was stats, second half mechanics. And like I said, there was a bit of an issue in terms of how I was going to write this paper and whether I include an extra question. But I think I'll leave it as it is. So I'm going to make the marks up slightly different. So as you'll see as you work through the paper, I think it's about 6 marks off slightly for the mechanics part here. But the stats part does add up to 50 marks. The mechanics part is 44 marks, but I'll just slightly distribute the marks ever so slightly different. So it does add up to 50. So if you're looking at this here, it will be less than 50, but on the actual PDF, it will add up to 50. So that's just why there's a discrepancy there between the actual marks on the paper and what you see here on the actual video. Okay, but there we have it. So like I said, it brings the end of this paper and this video on this Set A paper 3 exam walkthrough. Thank you very much for watching all of the video. It is quite a long video. As always, these full paper videos are quite long, but if you have made it, well done. And then finally, best of luck for the upcoming exams if you are watching this based on the 2023 exams. Like I said, good luck for the upcoming exams, and thanks for watching.